Hi, everyone. We're going to start in a couple minutes. Does anyone have questions in the meantime? Okay, we'll start in 2 minutes. If you guys have questions before we begin, feel free to either write it in the chat for just me to see or for everyone, or you can also use your microphone. Okay, just a question in the comments, or someone messaged me privately just now about the paper where we look at flip charts on student test score outcomes. And when we're talking about selection bias, we want to make sure that both groups are very balanced in characteristics so that we can find a causal effect. She asked why the flip charts can cause low ability students to take the test, and that would be a bad thing. So basically, the thing is that maybe if the treatment group receives flip charts, then students that normally wouldn't take the test, so students that receive low test scores normally, so they're below average, maybe they will be more incentivized to take the test because they have these flip charts. So more low ability students from the treatment group compared to the control group will take the test, and that will drop down the average treatment effect that we observe. So that would bias our results because then we think that the true effect is smaller than what we're actually it is. Because then everyone with low scores in the treatment side is taking the test and bringing down the average. So it's not that the flip chart is causing worse test score outcomes, it's that it's encouraging more low ability students to take the test. Any more questions? No problem. Okay, I hope everyone had a very nice Easter. I didn't know that Thursday was a holiday, so I worked. So now I'm crying to myself that I did work on Thursday when I didn't have to. But also, I posted your assignment on Thursday as well in the morning sometime. So that is due April 26th. Um, and it's basically the format that I talked about. It's going to be based on a data set that I provided to you, which looks at some sort of program, which is implemented. So it's this health subsidy program for households. So I want you guys to answer the questions. And if you have questions, you can email me or talk about it in class time, or we can set up a meeting as well if you need additional help. So that will be submitted individually by yourself. So I want you guys to submit so like a document, either Word or PDF, containing all of your answers. So basically, if I say produce output, I want you to make a table or some way to display your regression output. And also, when I ask you questions, just write it in words. I prefer English. And I know maybe writing in English is harder, but the grammar, this isn't a class on English, so the grammar doesn't have to be perfect. Just make sure that I can understand it, and that's fine. And along with your documents, so either your Word file or your PDF, I would like you to send your do file or your code that you run. So basically all the code that makes your output, just to make sure that you're doing your work and that you were able just to see what code you were running. And so I won't put too much weight on the code for the assignment, maybe just to make sure that you've handed in and that it's somewhat running. I will give that will be like 10% of the assignment. I should have wrote that in there, but I'll send an email. Okay. Everyone got the assignment, is aware that it's due on April 26th, so 2 weeks. Great. Also, just keep in mind, I know that the referee report is still a ways away, but I mean, it definitely is better the longer you work on it. So I would recommend picking your paper if you haven't already and start reading through it, because it's not enough to just read it and write a summary, but it needs to have actual critiques about the paper. So that's going to take some time to think about. So of course, do this assignment first, but keep the referee report in mind too, because you guys still have 2 other assignments. So yeah. Let me know too if the semester is feeling overwhelming. I know that we're in unique times with COVID. So if you feel like you cannot meet any course load because of the kind of state of the world or other classes that you're balancing, feel free to send me an email and we can work something out together. I know everyone has their own lives and problems. Okay. So if there's no questions, we will begin by finishing chapter 2, and then we'll move into chapter 3 today, which is randomization. Also, I have some exciting news. So I was talking to Marcos Agurto, and he told me that you guys will have a few guest lectures for this class, which is super awesome. So I think I mentioned already Vadim Marmer. He was a professor of mine at the University of British Columbia, and said he told me that he wanted to teach you guys something about machine learning. And then we have 2 other guest lectures throughout the semester as well that will teach you other topics within impact evaluations. We're not exactly sure what they will be yet, but they'll be super relevant, and these people are extremely smart and have lots of real life experience working in the World Bank and other areas of the field. So I hope you guys can learn a lot. So I'll let you know what dates those will be once we figure that out. So that's exciting. You don't have to see my face every lecture this semester. All right. Okay, so we will start with chapter 2 and just finish that. So I'll share my screen. Oh, wait. Okay, I'm sure if you guys were here at the last class on Wednesday, you will remember that we were just starting this paper called Legal Origins and Female HIV by Shu and Anderson. If you weren't here, it's a really interesting paper. I posted it on SIGA and I recommend you read it. It's basically a paper about HIV in Africa, in sub-Saharan Africa. And the author explains it by using different patterns in the legal system. So the origin legal system, which is based on whatever country colonized that African country. So that's where they gain their exogenous variation in legal systems. And of course, HIV is a serious problem in sub-Saharan Africa in particular. So approximately 80% of all HIV positive women in the world live in sub-Saharan Africa. Especially this is pronounced for adult women aged 15 to 24. They're 8 times more likely than men to be HIV positive. So this contrast for women to be much more likely than men to have HIV in sub-Saharan Africa is called the feminization of HIV and AIDS. But economists don't really understand why there would be such a difference between men and women. And so they think it's because of in sub-Saharan Africa, it's more cultural to have extramarital sexual relations more than other parts. So men are likely to go outside their marriage and engage in sexual activity compared to women. So that could be driving the spread among women more than men of HIV. And it's interesting because they compare, or she compares the difference in HIV rates between sub-Saharan Africa and Northern Africa. So Northern Africa is mainly a Muslim area, and they have a really, really low rates of HIV compared to sub-Saharan Africa. And the author attributes that to Muslims are more likely to have circumcisions, which is shown to reduce the spread of HIV, and also Muslim culture. It's more based on monogamy, so there's not as much extramarital sex. So it's normally husband and wife stay together, whereas sub-Saharan Africa, there's less circumcision and also more extramarital sex, which is really driving the high rates of HIV for women. Let me know at any time if you can't hear me. I just chatted. So, lower HIV rates in general. Oh, so for HIV rates in Muslim countries, it's in general, but of course, really what's driving HIV rates in sub-Saharan countries is women. So yeah, in Muslim countries, it would be more 1-to-1 from male to women, whereas you see this huge disparity in sub-Saharan Africa. Okay, so that's basically the motivation behind looking at the effect of this legal origins on HIV, because we see this gap in HIV between men and women, but we're not really sure why or what's driving it. So the hypothesis that the author is kind of exploring is that by strengthening women's property and inheritance rights, that would prevent the spread of HIV and AIDS by promoting women's economic security and empowerment within her own household. So, for example, negotiating power, when a woman is able to have more assets in her household or more financial independence, she's able to negotiate with her husband better for kind of equality or power in her household. And so that could actually cause a decrease in HIV rates if she has better control of sexual interactions and such. Okay, so the variation that the author is using here is differences in legal origin history. So as you all know, Africa was highly colonized by European countries, and so there was two different legal systems that came from that colonization, one of which was the common law. Those were previously colonized by countries such as France. Oh wait, no, that common law was by the British colonies, sorry. And then France, Portugal, Spain, Italy, or Belgium, they had legal systems following civil law. So you can see whatever countries colonized these African countries, that will tell us what legal system these African countries adopted when they became independent. And so that's kind of random, like the African countries don't choose who they get colonized by. So the author's kind of using this historical colonization pattern as exogenous variation because it's not endogenous. There's no choice for the African countries or culture in general. Okay, so there's different qualities about the two different legal systems that would affect the marriage or the female independence in a household. For example, the most important would be marital property laws. Down here, marital property laws. So the main difference between marital property laws and common law and civil law is that they treat the household unit differently. So under traditional common law, so the British system, a married woman basically had no legal rights. The male was considered the owner of the household, and she was part of that household. So her husband basically owned her. She wasn't allowed to conduct business, receive money. So if she had a job, she couldn't actually receive her salary. It went to her husband. So yeah, husbands were the sole owner of all property in the marriage under the common law system. In comparison, the system of civil law by France, Spain, Portugal, Italy, Belgium, all those countries, they gave females stronger stronger rights in the marital property rights system. So basically, they considered husbands and wives equal for their property. So they have equal rights to their property. If a male and a female divorce, they'll split those goods. And this is basically giving the woman a lot of power that the common law system doesn't have. Okay, so from this, the author develops a cause and effect question. Do formal laws that a woman's right within the household, so for example, those pertaining to marital rights or property rights for females, have any impact on female HIV infection rates? So she expects to find a positive relationship between common law and female HIV prevalence rates. Oh, sorry. So someone asked Giuliani, the difference between both types of laws is how they treat the family unit. Can I explain that more in depth? Of course, that's what I'm here for. So basically, um, the family unit, think of as a household, so it contains husband and wife and whatever children. Within that household, the common law and the civil law treat the household unit differently. So the common law treats the household system as though the husband are the sole owner. So the husband is really the only unit or agent that matters. So he will make all household decisions. He will receive all income. He will conduct all business. So basically, all legal assets fall on the husband, and the wife is considered his property. or his dependent, basically. She is dependent on him because although she can earn money, she doesn't get to keep that money. It goes to her husband. So she's basically working for her husband, and with that, he provides for her. So if they were to get divorced, for example, she would lose everything. The husband could keep it all, and therefore there's a larger incentive to stay with your husband because he has all the power. You cannot negotiate for yourself because if you do and it goes badly, you can lose everything. So therefore you're a lot weaker in the household. You don't have any power to hold against your husband in an uncomfortable situation. And with that, the author thinks that the woman will be less likely to tell a husband not to go outside the marriage to have extramarital sex, or even she won't be able to tell a husband to use protection during sex to protect herself from HIV. So that's why the author thinks there's a connection between a positive connection between common law and HIV rates is because in the household unit, the common law treats the man with all the power and the woman with no power in terms of assets and property. So she won't be able to negotiate for herself for safer conditions in her relationship. In contrast, we have the civil law, which treats men and the woman in the marriage equally. So whatever assets they earn together, they each own half of it. So maybe I earn 50,000, you earn 75,000. Well, we both get half anyway, so we're a lot more equal partners in this marriage. And if a woman wants to divorce her husband, she can do so knowing that she will receive 50% of everything they own together. So in that sense, she has a lot stronger of a voice and she's able to negotiate with her husband more for these things, for no, don't go have extramarital sex, or I'll divorce you and take half of your goods, or like use protection. So in this situation in civil law, you can see how a woman has a lot more power in a household. So yeah, that's basically why the author thinks she'll see a positive effect or a relationship between common law and HIV rates. Okay, no problem. So, yeah. Okay, so just some data description. Doesn't really matter, but if you're interested, she uses demographic health surveys, which has information on HIV and also demographic characteristics, which are important. And then they use GPS data to know where an ethnicity belongs. And then also recall that they're comparing between households right near a border between a civil law country, and a common law country. So if we have a civil law right next to a common law country, then we're just looking at households near the border within one ethnicity. So the author is concerned that maybe other cultural factors could be driving this effect. Maybe it's not just that the laws are driving the increase in HIV rates, but maybe it's more cultural. Maybe some cultures prefer within a common law system are more open to extramarital sex than civil law countries for some reason. So to cross that out, to make sure that selection bias doesn't exist, she is looking within one ethnicity, so then she can argue that um, this will be identical between civil and common law people in my comparison because they're within one ethnicity. So do you guys see how she's eliminating that selection bias there? Just by comparing between one ethnicity, you can control for a lot of cultural variables that would be hard to do otherwise. Okay. So when she does that, when she only compares within one ethnicity, between a civil and a common law country right on the border. She has approximately 108,000 women, so that's a really large sample still. And then she uses a regression discontinuity design, which we will talk about in greater detail in chapter 6, but I'm sure you guys are all somewhat familiar. It's when you have a discontinuous jump in your treatment. So basically, what she's doing is looking at the distance away from the border between a civil law country and a common law country. And she thinks that households right after the border will see a big spike in HIV rates compared to households on the civil law country. And that's just due to the bargaining power of a woman in the household that would increase the rates of HIV. Does that make sense? Or confusion? So I'll say that again more slowly just to drive it in. So the author is comparing between a civil law and a civil law and a common law country. So she's using distance to the border. And so she thinks that right after the border, when you cross from civil law country to common law country, there will be a big increase in HIV rates due to what we just talked about, that in common law countries, women don't have power in a household to have assets or property, so they're less likely to be able to negotiate good sexual circumstances for themselves. Okay. And so this is the variation she gets. You can see in this map. So this big map in the top left shows all the different rates of HIV by country. You can see, as we talked about earlier, sub-Saharan Africa has a lot higher rates of HIV than up north. They don't even show up here. There's like no cases in the very north. And then this top right graph shows common law countries right next to civil law countries, because we only want to keep the variation where we have a common law country next to a civil law country. And then panel C down below keeps the common law next to a civil law country, but only with the variation of one ethnic group across both. So that's what variation you're left with by the end. Okay, so this is our results. As I said, it's looking at a discontinuous jump. So you can see that the x-axis is distance to the border, and then the y-axis is female HIV rate. So what we expected to see was that when switching from a civil law country to a common law country, there would be a large increase in the HIV rates. And so she breaks the analysis between males and females. And what we see is basically confirming her hypothesis, right? So for people testing HIV positive, there's a really large jump for the females between civil law and common law. So that's just as the author said. But as for the males, there's not really a jump, and it's not statistically significant. If you had, I'm sure if you had confidence intervals on there, it wouldn't be significant. So you don't have a effect size that we can distinguish from zero, basically. So it's interesting that there's no effect for men, while there is effect for women. And that's because if you think about it, males still have household power in both situations, right? So either civil law or common law, they're going to have some control of property rights in the household. Whereas female, it's a huge difference between property rights and negotiating power between civil law and common law. So these results kind of do make sense. And they're pretty shocking, honestly, that just the legal system can create such a difference in HIV positive effects. So, okay, and then they look at what could be driving this effect. So they look at protection. So basically whatever sexual protection they're using. And interestingly, I mean, not surprisingly, we see a decrease from civil law to common law for protection, right? So as we said, there's an increase in HIV rates, and also we see a decrease in protection, which is probably why there is a lot of HIV increase or positives in common law compared to civil law. And so, yeah, that's using the same measure. So looking at distance from a border between civil law and common law. And right at the border, we see a huge drop in protection, which really can't be driven by anything else besides the legal origin, because we're controlling for ethnicity. So any cultural factor, any language factor must be controlled for. And then same for males, we see a drop in protection as well, which makes sense because it's a two-way dance. So yeah. Okay, and then this is the table results. Basically what we just looked at. So basically the effect of switching from civil law to common law country on being HIV positive. I'm pretty sure they just made HIV positive a dummy variable, so they have a full sample population of females, and if you're HIV positive, you have a dummy variable equal to 1, if not 0. Okay, so you can see that they look at differences or distance to the border. So this is less than or equal to 200 kilometers, and then it gets closer, so 150 and then 100. And the results are very similar. So basically they find an effect, or she finds an effect size of, if you are in a common law country, the probability of having being HIV positive, it increases by like 1.6 to 1.9%, which is very statistically significant. And then they compare between the non-Muslim, non-polygamous, and then Muslim and polygamous. Okay, what? So this is interesting. Okay, so they just wanted to look at I'm thinking the non-Muslim, right? We said that Muslims had lower rates than non-Muslim, but then polygamous is like multiple sexual partners, so you would think that the rates would be higher for with more sexual partners than less. But here they're looking at non-Muslim, non-polygamous. But even if you control for the fact that it's non-polygamous, so that's not all that there is. Like, it's not just that there's this extramarital factor, there's still a significant effect, and it's basically the same as what we see for the whole sample. So it must not just be the fact that there's this cultural extramarital sexual relations going on. It seems a lot more also to be driven by the actual common law versus civil law. And then interestingly still, for the Muslim population, even though we're only looking at polygamous Muslims, so Muslims that will go have extramarital sex or have more than one partner, the effect is a lot lower. So if Muslims had a common law system, but still were polygamous, so extramarital sexual encounters, the probability of having HIV positive is still lower than in sub-Saharan Africa. So that's kind of an interesting one. Any questions? Nothing. Okay. Okay, so when you're thinking of a causality in a paper, you always want to have concerns about whether they actually obtained a causal effect or whether the effect is accurate. So maybe there's a possibility that besides legal origins, there's some other institutional channel that is affecting economic development outcomes and therefore affecting our HIV infection rate outcome. However, the author is arguing that, I mean, I can't think of anything because the only other thing I could think of that would affect this HIV rate so drastically would be culture, which the author is controlling for, right, by comparing within one ethnicity. So that's really convincing to me. And then also, the literature has argued that, wait, oh, so basically they're saying that in terms of other channels, that typically common law has better economic outcomes compared to civil law because they have other legal aspects that actually make common law improve economic development more than civil law, and that actually is ironically has to do with property rights, but it's just that property rights are awful for women and good for men. So in anything, this is kind of a counterintuitive result. And like really, because these results would be opposite if we were looking at other economic outcomes, we know that it's not driving some other economic outcome that's then driving HIV, because the two legal systems would have the opposite effect in terms of other economic outcomes. Okay, oh man, still got another paper. So this is another AIDS paper. So the economic consequences of AIDS mortality in South Africa. So actually I'm showing you guys this paper because I mean it's published to a good journal, but to me the methodology isn't very convincing. So try and think of the comparison groups they're using in this paper and whether you think it like obtains causality. Okay, so the motivation, of course, AIDS is a serious problem we just talked about. It's incurable and it can be very costly to households. So within sub-Saharan Africa, again, this AIDS epidemic has increased the economic vulnerability of households. So AIDS deaths, when you die of AIDS, it's normally preceded. So before you die, there's a large period of illness. In that period, usually household members have to provide care to those who are sick from AIDS and also contribute to medical expenses. So basically, AIDS can then reduce household income through the loss of a prime-aged worker. So maybe through someone who's actually helping take care of the sick person, they can't go to work then because they have to take care of their family full time. So that's a loss of income. And then secondly, through the expenses of drugs and medication. Also even for elaborate funerals, I know in India and some parts of Africa, it's really common to just put all of your savings into a funeral. It's kind of a sign of respect, and families will do that, but it will really put a huge financial burden on them. So that's another reason why AIDS death can be so expensive. Okay. So basically, the author is looking at how AIDS affects household economic outcomes. Of course, this is an important question where AIDS is still really common in sub-Saharan Africa, and can provide motivation on how policymakers should try and just decrease the spread. However, like this is a really hard estimate to attain. If you guys can think about all of the selection bias in this estimation. So what would you guys think, for example, if we ran an OLS regression of dying of AIDS? So say you have a household, one person in the family dies on AIDS, and we look at the economic outcomes for that family. So it could be income, it could be what they are on the poverty index. Oh no, my dog. I'm scared. So poverty index. Jake! You guys want to see my dog? No. That was funny. Yeah. Oh my god, I'm sorry. Good dog. Yeah. That was my dog. His name's Jake. All right, so there could be a lot of different consequences, I guess, running an OLS regression, because if you think about it, which way is the direction going? Is AIDS causing worse economic outcomes, or are worse economic outcomes causing AIDS, right? Maybe it's just that if you live in a poor area, you have a lower education, you're more likely to get AIDS and die because you're just not as well informed or protected. So it's really hard to say which way the relationship's going. It's probably a bit of both, but the authors want to know how AIDS specifically affect the economic outcome. So they need to find that one-way channel and not pick up the two-way causality. Someone said, but most households in sub-Saharan Africa are poor. Would there be a substantial difference? I mean, it depends on the data, but I would say yes. Like some households are going to be richer than others, and even that variation can create differences in HIV and AIDS. Like even say maybe all of us are poor, but there are some people that live in a really poor neighborhood, which has really high rates of HIV. So just belonging to that neighborhood makes you more likely to obtain AIDS just because it's being spread in that area. Whereas maybe I have I have a little bit extra money and I can live in a different neighborhood that doesn't have the same problem. So yeah, yeah, I don't know. I think they're like you do want to control for that, even if it's a poor area in general. No problem. Okay, so the author's collecting data on HIV. So they want to know if someone in a household has died of AIDS. So even the problem could be that poor households, like there's a difference in reporting of AIDS between households. So maybe richer households or more educated households or households with better access to healthcare are more likely to report that someone had AIDS, whereas really poor households, they don't have the same sort of healthcare and they won't report if someone in their house has AIDS because they can't afford to do anything about it anyways. So then there would be a selection bias in the reporting of which households had someone with AIDS and which didn't. And that would, of course, be a problem too, because then we're saying, oh, like these households that are more rich are having more AIDS deaths, which is the opposite of what might actually be happening. So to make sure that there's accurate reporting is really important. So the authors say that they have this because they use this African Health Center data, which basically does autopsies on bodies and they can tell when someone dies of AIDS. Even still, that might not be good enough because who's to say that all of these people are bringing their families to this center of health once they die? Maybe they're just getting like this tribal burial and they're not even taking them to a health place. So that alone could be biased as well. So they're using households over the period of 2000 to 2008. And they have different survey rounds. So they have 8 survey rounds. And information was collected on assets, education, other demographic characteristics. And then they're looking at the consequences of adult deaths. So they'll compare AIDS to other types of deaths on economic outcomes. Okay, so you can see here, this is kind of just like a general descriptive table. So, still laughing at my dog. So you can see different age categories. So 0 to 5, 6 to 9, 10 to 19, 20 to 29, and so on. And then they have different causes of death. So there's AIDS, there's a sudden death, so maybe a car crash, some sort of accident. And then chronic illness would be something that persists over time. I don't know, just think of any disease other than AIDS, I would say, or cancer, something like that. Unknown cause, yeah. Diabetes, for example, yeah, diabetes would be chronic illness for sure. Okay, so look at the proportion of AIDS deaths across age categories. So I'm gonna check something. You can see 36.5% is attributed to, wait. Each cell reports the fraction of deaths attributable to. Okay. 36, 50. Okay, so I think all these should add up to 100. But 36.5% would be contributed to AIDS for like 0 to 5-year-olds. And similar rates between 6 to 9 and 10 to 19. And then there's a huge jump for 20 to 29-year-olds and 30 to 39-year-olds. So it's about like 60 to 66% of all deaths are caused by AIDS, which is extremely, extremely high. And then after 40, it goes down again. And that's basically the ages of most sexual activity, I'm guessing, so that's why. But then you can look at other deaths, like sudden deaths are really common. It stays pretty high throughout the life cycle, but it's definitely the highest for 10 to 19-year-olds at 50%. Chronic illness takes a relatively small share of deaths, but is highest for old people, which makes sense. Unknown causes doesn't tell us anything, so it doesn't matter. Okay. So, table 2 shows the proportion of household deaths within the same population. Oh, sample population. Okay, so within the sample, the author sees that 4.6 households had an AIDS death. 4.6% of households had an AIDS death. 1.5% had some other chronic illness death in the household, and then 3.3% had a sudden death in the household. And that's of a sample size of almost 8,000 households. And among these households, about 35% reported themselves to be poor. Also, never trust self-reported data normally, because we'll talk about it a bit in randomization, but there's always like a behavior incentive to report yourself if you think there's something, if you think it will benefit you in some way. So like if they're taking the survey and the households think that they might get something or be put into some sort of group for treatment if they receive, or if they say that they're poor, maybe they're going to understate their income level, or maybe they feel embarrassed and they want to overstate their income for some reason. They don't want people to know how poor they are. So I don't know, it could be biased. So there's always a lot of noise in this data. Okay. Yeah, as we talked about, the problem with analyzing the effect of this death in the household on economic outcomes is that there's this two-way link. On the one hand, that a death in the household could be causing decreased finances or income because of all the costs associated with death. On the other hand, poor households just might be more likely to have someone die. So yeah, basically poor households have poor access to clean water, nutritious foods, healthy work environments, and that could lead them to having earlier deaths and higher levels of death. Yeah, on the other hand, the causal effect that she's interested in is that individuals that get AIDS will become too sick to work. Maybe someone in the household also has to stop working to take care of them. And also it draws down household assets to pay for expensive medical treatment. So the author is using basically a panel of data, so over time. And so she's going to use a type of fixed effects model. So basically what she does is compares between a household before and after the household has someone die. Okay, so this is the specification. Doesn't really look clear, but the outcome variable that they're going to look at is assets for household age and time t, where there's 3 different causes of death they look at. So C is the type of death, and so there's either sudden death, AIDS death, or chronic death. So there's the 3 different types. And so they're putting all different types of deaths as a dummy variable. So for each time period. And then they also include fixed effects for the household. So X is a set of characteristics or controls that they want to control for. So basically they're saying having a dummy variable for each type of death. And so if the household has someone that dies of AIDS in period T, they'll have a dummy variable equal to 1 for that. Yeah, so then they're looking between basically 5 to 6 years before the household has a death, and then 4 to 5 years. What? Just like different year ranges for when the household had a death. And then they also include indicators that a death occurred within years in the future. So basically they're trying to show that that's like a reverse causality solution, so that they want to show that the poor, like a household being more poor, isn't driving the outcome, but it's just that the household has an AIDS death that's driving the outcome. So your outcome shouldn't be predicted by any outcomes before the period of death. It should only matter once the household receives treatment or basically has someone in the household die. But this model is like never used. They're basically doing a before and after comparison, which we talked about on Wednesday. And do you guys remember what the problem of the before and after comparison is? Anyone? Well, the problem of before and after comparison is that even though they're comparing within one household, they can't really compare or control for things that change over time. So other things besides this AIDS death might be affecting their financial outcomes, which they're really not addressing in this. Yeah, exactly. So Susanna says that it's time variant, so other things could have happened. Exactly. We don't know what else is happening. So that's why their strategy isn't really convincing to me. Also, these graphs that they show, which is actually they're trying to use to argue their case, but somehow to me it seems like it's going against what they're trying to show. So here shows the relative asset index by cause and timing of death. So remember that they're trying to attribute AIDS deaths to a decrease in assets. So they want to show that at year 0 of a household having someone die of AIDS, assets will decrease. This graph shows the freaking opposite. It shows nothing. It shows that, so this is the average assets, this red line, and then below it, this is like the asset index for houses that have a AIDS death in the household. Well, they just show that AIDS households are poorer than the average household, and that at year 0, like this is years before death, there's literally no change in assets. So literally any effect that they're capturing of AIDS on assets is just the fact that households with AIDS are poor. Like you don't see any decrease after the period, right? So what are they capturing? Just saying. And then look, so for sudden death, you can see there's a decrease in assets at time 0. What kind of? Yeah, I would say that's decrease. So if you have a sudden death in the household, sudden deaths tend to be around the average wealth, average assets before the time of the death. And then after the time of the death, you can see year 0, there's a clear decrease that they're consistently below average assets. So this sudden death was really sudden and maybe random, for example, that is actually dropping the assets down. Whereas the AIDS one, it's clearly showing that families with AIDS are just poor to begin with. So that's not causal. And then chronic is just similar to AIDS, but a bit higher up on the income level. So they tend to have higher relative asset index than does the AIDS. So when comparing AIDS households, their assets to chronic and sudden, you can see why we're showing that the effect is lower, or assets are lower for the AIDS households. It's because they're lower to begin with, not because the death is causing a sharp decrease in assets. That's what I said. Okay. This is just more nonsense. I'm not even. So this is their results. So you can see that they find AIDS death has a decrease in assets after the time of death, but it's between survey rounds. So survey rounds are also every 2 years, so it's not a sharp difference between before and after. It's like 2 years before, 2 years after. So like so much other things can change in that time. It's not precise at all. So yeah, you can see they find negatives for all. They can see negative effects for AIDS and sudden death, but not for chronic. But clearly, as we talked about, the AIDS effect is just selection bias. I'm not here for it. So I hope if you guys read a paper, you'll be able to understand whether or not to be convinced or not based on what methodology they're showing, and also descriptive statistics. Like when we looked at the legal origins paper, to me it was really convincing, whereas this paper is just straight, it's not garbage, but it's just not causal. So she's really saying that there's an effect when there isn't one. Okay, any questions? Preguntas? Okay, let's take our break. Oh, wow. Come back at 6:13. Okay, I'm gonna hide myself and mute myself. If you have any questions, chat me, I'll be here. All right, let's start again. Any questions on chapter 2 before we switch to chapter 3? Nothing. Is anyone still here? That's the more important question. I think that is a yes. Everyone's here, ready to go. Nice. Okay, get hype. So, switching to 3. I want to know how your old professors are doing on Zoom. I feel like this is hard for me. I can't imagine old people. Oh, all right. Um, okay, yeah. So chapter 3 is randomized control trial. So this is our first methodology we're going to be looking at. So far, we've done an introduction to impact evaluations and then talked about the problems such as selection bias, counterfactual problem, just in general causality. So those are what we've talked about so far. Now we're going to start looking at methodologies on how to address these problems. So as an economist, you need to have tools if you want to work as an analyst. So this is our first tool that we're going to look at, randomized control trials. So yeah, the biggest problem in terms of economic research is finding a valid counterfactual group. It's really hard. It's not easy, it's hard. So yeah, basically, depending on how our program is implemented, will help us decide what evaluation strategy we should use. So the problem is that when we're looking at a program, at the same time a program is being implemented, there's so many different factors changing, and we have a complex and changing environment all the time. So how can we isolate for that one effect of the program that we really care about when this whole world around us is also changing? So dramatic. Um, okay, yeah. So economies change, prices change, governments change, preferences of individuals and households change, and all of these things make it really hard to find the effect of only our program of interest. So what do we do? Oh my god, I'm so lonely. Okay, so we already discussed two bad estimates of the counterfactual. So we talked about before and after comparison, and also enrolled versus not enrolled, right? So the before and after was individual I before he received treatment compared to after received treatment. And the problem, as Susanna said, that there is other factors that change over time. So time variant factors that will also affect our outcome. And then looking at enrolled versus not enrolled, we're comparing two different groups. So what was the problem there? Someone tell me. When we have enrolled versus not enrolled, what is the bias? Quentame. Selection, I think, says Nicholas. Yes, selection bias. So there's differences between the two groups in characteristics that will also affect our outcome, making it impossible to find out what just the effect of the program is. Yeah. Also, in other words, Susanna said it's constant across time, but not across people, right? So it's time invariant factors. So just differences between individuals that will affect our outcome. Okay. So randomization is our tool that we will use to evaluate our programs for this chapter. So randomization is considered the gold standard of impact evaluations. That is because we can be absolutely certain that we eliminate selection bias. It's foolproof. If you have randomization, you are golden. You are king. Okay. So on the other hand, it's expensive. So from a cost benefit analysis side, maybe there's other types of impact evaluations we could do that would find similar results but cost us a lot less money. So that's always a trade-off too, because when we run a randomization, we need to collect data from households, we need to set it up, we need to hire researchers, the full operation, right? Because we're actually giving households some sort of treatment, so just to organize all that can be expensive. So yeah, unlike other methodologies, such as an OLS with controls, fixed effects, differences in differences, instrument variables, regression discontinuity design, randomization basically guarantees removing selection bias, and therefore it's really desirable. Also, randomization, unlike other methodologies, removes publication bias associated with non-experimental research. So publication bias is basically when an editor or an author or policymakers in general might have some preference for some results more than other results. And this could affect what kind of research gets published. That's why it's called publication bias. And they might not even realize they're doing it, but it's way more easy to do in non-experimental research than experimental research. For example, people tend to have this kind of common beliefs. So maybe we were expecting a positive result from this treatment, and then with an experimental approach, so if we have a randomization and it shows a negative effect, we're more likely to accept that as a true effect because we're so confident in the randomization study that it's true. However, if we had a non-experimental evidence and we showed an opposite sign, we'd be more likely to say, that's wrong, where's the bias, what's missing in our controls, and we're more likely to adjust our specification until we get a result that looks what we wanted. So that's called kind of like data mining or p-hacking, where we're trying to change our results to get a result that or change our specification to get a result that we expect to have. And that's publication bias, really. Even as far as a journal, maybe if I have unusual results or you don't expect my results in my paper and it's an experiment, the author, the journal will be more willing to accept it than if it's non-experimental, because then they'll say, no, there has to be something wrong with your research if it's non-experimental. So in that way, randomization does remove a lot of publication bias. So yeah, ultimately, publication bias is not good because while it will lead to papers being published that support commonly held beliefs, but even if the results aren't true. So of course, we only want to publish results that are truly measured. And if there's some sort of publication bias in favor of some results over others, then that's not going to be the case. But yeah, randomization is effective at removing publication bias just because results are so trustworthy that they'll not usually be denied if there's a weird or unusual outcome. Okay, now now we're going to show why randomization removes selection bias, and it's through the random assignment of individuals into treatment and control groups. Okay, so we're randomly saying what people go into what group, and by that we're distributing characteristics evenly across the two groups. So that's the premise of randomization. So for example, a sample of n individuals are randomly assigned either to the treatment group or the control group. Do you guys remember what DI is? You can tell me. We talked about it in the last chapter. We're gonna use it always, so just worth remembering. Well, DI is, oh, someone, yeah, let's see. Dummy. Yeah. Oh wait, someone asked the question. Randomization trials are part of prospective methodologies. Yes, so randomization trials are part of a prospective methodology because we're starting the analysis at the very beginning of the implementation. So that allows us to obtain baseline data before people are even treated. So it is prospective, yes. Yeah. Oops. So like Nicholas and Susanna said, DI is a dummy variable for treatment. So if you receive treatment, whatever the program is, we're just making it a general treatment, then DI equals 1. Yeah. If you don't receive treatment, you're in the control group, DI equals 0. Okay. So super simple, DI is dummy equals to 1 when you receive treatment, equal to 0 when no. Okay, remember DI is randomly assigned. They were rolling dice to say, oh, you're getting treated, you're not. Completely random. So since DI is assigned randomly, it will be independent of potential outcomes. So look at this equation here. You see that the expectation of yi given DI equals 1. So yi is our outcome, right? And then DI equals 1 means you receive treatment. Minus the expectation of our outcome variable given DI equals 0. So that's our control group. So of course, this is our kind of outcome of interest. What is the difference in outcomes between the treatment group and the control group, right? That's always what we're estimating, our effect, just in terms of expectations. Everyone can understand that, how that would be our outcome of interest. Okay, so then, remember our two potential outcomes, y1i or y0i. You can only observe one of the two, right? That's our counterfactual problem. You can never observe both potential outcomes. So you observe y1i if you get treatment and y0i if you don't, right? So then our function, our expected value of yi given di equals 1 here at the beginning minus expectation of yi given di equals 0 is equal to our expectations of potential outcomes. So we see the expected value of y1i given di equals 1. So that's our treated person goes and gets treatment, right? That's our potential outcome. So what's the outcome for the person that gets treated and is put in the treatment group, right? So you put in the treatment group, di equals 1, then you observe your potential outcome, yi1. On the other hand, you're put in the control group, di equals 0, and you receive potential outcome y0i. You can see how you have the two groups and it gives you two potential outcomes. But the concern is that differences in y0i between the treatment group and the control group, that's causing a selection bias that is affecting our outcome, right? So even to begin with, maybe remember the health example, people that go to the hospital are more sick than people that don't. But when we randomize between treatment and control group, on average, the characteristics between treated and controls will be the same. So that's why we can replace this first line with the second line, where we can say the expectation of y1i given di equals 1. you can subtract the expected value of y0i given di equals 1 because, can you guys see my mouse? Because these two terms are equal in randomization. You can see that y0i for the control group is equal on average to y0i for the treatment group because we randomize who receives treatment and who doesn't. So these characteristics before treatment, right? This is when you don't receive treatment. So these characteristics when not receiving treatment, or even actually to say the outcome before you receive treatment, is the same between the treatment and control group. Do you guys have questions on that equation about why those two lines would be equal to each other? Because it's a really important concept. All right, just to repeat, the reason that we can say we can put this top part equal to the bottom part is because we can say that the y0i for the treatment group is the same on average as for the control group due to randomization. And you guys will notice that there's no selection bias in this equation. And that's for that reason. That's because the y0i is the same between the two groups on average. So there's no selection bias. So that's how it's eliminated through the random assignment of DI, the treatment status. And that makes DI independent of potential outcomes, right? So then your y0i isn't determining your treatment status. I'm not saying, oh, well, I'm sicker, so I'm going to go to the hospital. That would be the y0i determining your treatment status. That's not happening here because sicker people don't get to choose to go to the hospital. You are told whether you go or not based on a random draw. I think that's pretty clear. If not, let me know. Okie dokie. All right, moving on. Okay, so what we just talked about, that's known as the independence assumption. Okay, and that's because the baseline outcome of interest, y0i, does not depend on di, and that's why you're able to substitute the last term. So that's why you're able to say that the expected value of y0i given di equals 1 is equal to the expected value of y0i given di equals 0. Okay, I have a really good question. Susanna asked if it's necessary to test the average characteristics across groups to test whether these characteristics are identical, or that we can assume that they are because of randomization. Always test it. So the answer is yes, you should test, although the principle of randomization should guarantee this. It's important to show that it does. So always show a table, making sure that there is balance between the characteristics. And that's especially true if you have a smaller sample size. The larger the sample size is, the more likely it will be perfectly balanced. But when you have a smaller sample size, so maybe 50 people untreated, 50 in control, then it's more likely that maybe some variables will not be perfectly balanced. And so it's important to know what variables are not balanced, because if they aren't, well, it could affect our estimates. It could bias our results. So always check, because it's not necessarily guaranteed randomization. So you have to randomize after proving that all the individuals are statistically identical. No. So to begin with, they will not be statistically identical. Say you have 100 people, they're all different in so many ways, but when we randomize these 100 people into two groups, so 50 treatment, 50 control, since we randomly say where they're going, then the two groups, if we take average characteristics, then the averages should be identical. So of course, like for group treatment, there's going to be a huge range in age maybe. So maybe someone's 12, someone's 50. There's a lot of variation. And then maybe group B has like a lot of 25-year-olds. But on average, we should get the same average age. Maybe they both have the average age of like 30. So that's really important that we have that. But of course, before we randomize, that's not going to be true. It happens after. Yeah. De nada. Um, okay, so yeah, this independence assumption is really important because it's ensuring that there's no selection bias. SD is also important in that sense. You mean standard deviation? Yeah, yes. Yeah, because for example, it was important because it's common to do a difference test. So you basically divide the averages. You subtract the averages, so treatment minus control, and then divide by standard deviation. And that will show you if they're statistically different or not. So we do use standard deviations for that. So yes, they do have value. So in this case, what is the yi? Yi in general is just the outcome. So yi can either be y0i or y1i, and those are your two potential outcomes. So y1i is your outcome if you receive treatment, and y0i is your outcome if you do not. In this case, we don't have an example, but I mean, you can think of it, we're kind of talking about that health example, so it could be your health outcome. So what is the effect of going to a hospital, for example, on your health? So health would be yi, and then we say who goes to the hospital is random. We randomly say you go to the hospital, you don't. And so then these two groups will have people who go to the hospital and people who don't, and that will be chosen randomly. That won't be chosen by, oh, I'm sick, so I think I should go. Oh, I feel fine, I won't go. So then there's no selection bias. So then we can analyze the effect that we put people into the hospital on their health. So yeah, yi is just outcome. No problem. So yeah, I'm just gonna do something. I'm gonna share my screen again, even though I said or whiteboard, even though I said I hated it. I do hate it. Just to clarify. So we have our yi. So yi is our outcome, right? Oh my god, so slow. Oh, I can text. That's way better. Okay, so from yi, we have two potential outcomes. Y1i, y0i. Oh, that looks so. Ah! Wait, where'd it go? Oh, okay. Right? And then draw. The I is our treatment. Oh my god. Ooh, I should not say that. Never mind. Don't listen to me. Okay, so di equals 1 if you're put in the treatment group, and then I just wanted to make that difference for you guys. So these are your outcome variables. So your yi is the outcome you observe. So whatever my health status is, for example. So yi would be my health, how high my health is if I receive treatment, and yi is my health if I don't receive treatment. And so remember, only treatment groups would receive outcome y1i, and control groups would receive y0i. But DI is your treatment status, so it's the treatment you should be receiving. So basically, DI equals 1 is I'm assigned to be treated. So you're put into the treatment group, and then DI equals 0, you're put into the control group. I just want to make this difference because there's some times where your DI might equal 1, but then you observe Y0I, so you're not treated. And that's an example of you're not complying to treatment status, and that affects our estimation. So just because DI equals 1 doesn't necessarily everyone will observe Y1I. But let's just consider a case for right now where if DI equals 1, everyone in D equals 1, their YI equals Y1I, right? In experiments, do people always know which group they are in? Maybe not necessarily the control group. The treatment group will, of course, know they're receiving some sort of treatment because it's pretty obvious if I'm getting 1,000 extra bucks a month or whatever the treatment is. But the control group might not know that they're in the control because if we tell them, actually, they will never know that they're control group because if you tell someone, hey, sorry, we're giving all of your friends 1,000 bucks a month, but you don't get anything, sorry, you're in a control group, they won't be happy, and that also might affect their behavior, which would affect our outcome. So we really don't want the control group to know that they're controlled or in the control and not receiving treatment, because that would have some negative consequences. But the treatment group would know. Okay, I'm gonna delete this. It's ugly. Girl, you ugly. Oops. Okay. So, yeah, where are we? So that's the important feature of the randomization is that we can say that the Y0I on average for the treatment group is the same as the Y0I for the control group. That's what is eliminating the selection bias. Because if you remember in chapter 2, if you went back to that equation about when we find the effect, so the effect between the treatment group and the control group is a treatment effect plus the selection bias effect. And the selection bias was the difference between Y0I for the treatment group minus Y0I for the control group. So if we're saying they're identical on average, then there is no selection bias. I think I show that. Okay, so since we have removed selection bias, we can run a simple OLS regression to find causality. So then we can just run our yi as a function of alpha plus beta di plus our epsilon or error term. And we know that this di is our treatment effect. So, yeah. Any questions? We should stop. Okay. Email me if you have anything before Wednesday. If not, I'll see you on Wednesday. Have a good night, everyone. Ciao.